Most people think Betelgeuse is just a bright red star. It's not. It's a star that broke the laws of physics, a star that may have already exploded. And everything you're about to see is 640 years old. Look up at the constellation Orion on any clear winter night. Find the three stars of the belt, then look to the upper left. That warm orange-red point of light, slightly different in color from everything around it, slightly unsteady in its glow, is Betelgeuse. You can see it with your naked eye. Your ancestors could see it. Every civilization that has ever tilted its head back toward the night sky has seen it. Betelgeuse has been sitting in the shoulder of Orion for the entire recorded history of human observation. And in all of that time, through every civilization, every telescope, every measurement ever made of this star, nobody noticed that something was deeply fundamentally wrong with it. Not until recently. Here is what we now know. Betelgeuse is rotating at a speed that the laws of physics say is impossible for a star of its size. In late 2019, it started vanishing, losing 2/3 of its visible brightness in weeks, in a way no known model of stellar behavior could fully explain. Measurements suggested it might have a hidden companion star, a second body orbiting so close it was embedded inside Betelgeuse's own atmosphere, invisible to every telescope ever pointed at it. And then, in December of 2024, someone finally found it. Each of these pieces on its own would be extraordinary. Together, they are building a picture of a star so strange, so violent, so fundamentally unlike what our textbooks predicted, that astronomers are not merely revising their models. They are starting over. And there is one detail buried in all of this data, a possibility that nobody in any official paper wants to say out loud, that we are going to come back to before this video ends. Let's start with the scale. Because until the scale is correct, nothing else in this story lands the way it should. Betelgeuse sits approximately 640 light-years from Earth in the constellation Orion, marking the hunter's right shoulder. To the naked eye, it sits reliably among the 10 brightest stars in the sky. It is red distinctly, visibly warmly red in a field of white and blue-white stars. That color is your first clue that something unusual is happening here. White and blue stars are young, hot, burning fast and clean. Red stars are the opposite, cooler by stellar standards, around 6,000 degrees Fahrenheit on the surface, and almost always either very small and stable or very large and deeply unstable. Betelgeuse is the second kind. It is a red supergiant, and that classification does not begin to capture the reality. If you took Betelgeuse and placed it where the sun is right now, at the center of our solar system, it would not stop at Mercury. It would not stop at Venus, Earth, or Mars. Depending on which size estimate you trust, it would extend somewhere between 2/3 of the way to Jupiter's orbit, and past Jupiter entirely. Hundreds of millions of miles of glowing, churning, boiling plasma extending outward from where our sun used to be. Stand outside tonight and genuinely try to picture it. A single object so enormous that if you placed it at the center of our solar system, you and your house and the entire Earth and every planet out to Jupiter would be deep inside it, with more of the star still stretching outward in every direction beyond that. That is what is sitting in Orion's shoulder, and it is not stable. It pulses. It heaves. The surface boils like a pot of tomato soup the size of a solar system. Convection cells the size of 1,000 of our suns rise and fall in slow, irregular waves. There is no calm Betelgeuse. There never has been. What you see when you look at it is a star in its death throes, just at a pace too slow for a human lifetime to register. Or so we thought. In October of 2019, astronomers noticed something. Betelgeuse was getting dimmer. Not a little. By December, it had dropped noticeably. By January and February of 2020, it had lost roughly 2/3 of its visible brightness. To anyone looking at Orion that winter, the shoulder was wrong, visibly wrong. You did not need a telescope. You needed eyes. This had never been seen before. Betelgeuse is a variable star. Its brightness fluctuates on known cycles, including a roughly 400-day rhythm. But none of those cycles in any combination produced what happened in early 2020. Something else was going on. The astronomical community went into something close to a frenzy. Papers were rushed. Telescopes were redirected. Theories piled up. The most dramatic one, the one that lit up every science platform and every concerned message sent between amateur astronomers, was simple. Betelgeuse was about to explode. A red supergiant goes supernova at the end of its life. It collapses. It bounces. It detonates with a brightness that can briefly outshine an entire galaxy. Astronomers had always known Betelgeuse would do this. The question was always when. And watching it dim in real time, the answer suddenly seemed to be soon. People sat outside in the cold and looked at Orion the way you look at someone you love who might not be there much longer. Then it came back. By April of 2020, Betelgeuse was rebrightening. By summer, it was back to its normal range. The death watch was over, mostly. But the question of what just happened was completely open. By 2021 and 2022, using the Hubble Space Telescope and a network of ground-based observatories, researchers pieced it together. A massive plume of plasma had been ejected off Betelgeuse's surface, hundreds of times larger than any flare our sun has ever produced. As that plasma cooled, it condensed into a dust cloud. At the same time, the region of surface that had launched the material was now cooler than its surroundings. Earth had been looking through a dust cloud at a cold spot at the worst possible angle. That sounds like an answer. It isn't. It just shifts the question. Because why did Betelgeuse suddenly eject that much material? Stars do not normally spit out mass equivalent to several moons in a matter of months. Something was driving it. Something underneath the surface. Something the standard models had not predicted and could not explain. And as more data arrived over the following years, the picture only got stranger. Here is a experiment that has been sitting in astronomical data for years, quietly making no sense. Betelgeuse is rotating too fast, not slightly too fast. Embarrassingly, impossibly, physics-breakingly fast for a star of its size. To understand why, you need to understand a basic principle called the conservation of angular momentum. When a spinning object expands outward, it slows down. The same reason a figure skater spreading her arms rotates more slowly than when her arms are pulled tight. The larger and heavier a star is, the more slowly we expect it to spin. Our sun rotates at about 2 kilometers per second. If you expanded it to Betelgeuse's size, 1,000 times larger, while conserving angular momentum, its rotation speed would drop to roughly 0.2 meters per second. A slow, dignified crawl. Betelgeuse is rotating at approximately 5 kilometers per second. That is 18,000 kilometers per hour, 10 times faster than the surface of Earth. And for a star the size of Betelgeuse, it is, by every standard of normal stellar physics, impossible. The star should not have this much angular momentum. The mechanisms of standard stellar evolution cannot produce it. Measurements from the ALMA array of telescopes confirmed the figure using Doppler shift analysis. The same effect that makes an ambulance siren change pitch as it passes. When a star rotates, one half of its surface moves toward us while the other moves away. That motion blue shifts light from one side and red shifts light from the other. By measuring that color gradient, astronomers calculated 5 kilometers per second. Every measurement agreed. And then a team of researchers collaborating across Europe and China suggested something that reframed the entire problem. What if the rotation isn't real? Remember what ALMA actually detected. One half of Betelgeuse's disk emitted slightly redder light than normal. The other half emitted slightly bluer light. The obvious interpretation of that 50-50 split is rotation, one side moving toward us, one side moving away. But Betelgeuse's surface is not smooth. It is a violently turbulent place, constantly bubbling under its own heat, with convection cells dwarfing entire solar systems, rising and crashing back in perpetual chaos. A single bubble on Betelgeuse's surface can be 100 million kilometers across. Those bubbles propagate outward at up to 30 kilometers per second. The surface is a patchwork of regions simultaneously moving toward us and away from us. Rising gas blue shifted, falling gas red shifted, scattered across the disk in a constantly shifting mosaic. A rotating star should produce a smooth gradient, blue on one edge grading evenly to red on the other. A turbulent star should produce a random patchwork, blue and red scattered irregularly, no smooth transition. Those two patterns should be easy to distinguish, except Betelgeuse is 640 light-years away. Even ALMA cannot produce a sharp image at that distance. What it captures is a blur. And when the research team ran simulations of Betelgeuse's turbulent surface through ALMA's known resolution limits, they found something deeply unsettling. The turbulent patchwork would be mistaken for a rotational gradient approximately 90% of the time, 9 times out of 10. ALMA would look at a turbulent Betelgeuse and conclude with high confidence that it was rotating impossibly fast when the rotation was never there at all. Betelgeuse's violent boiling surface might be generating a giant optical illusion. a fake rotation signature written in the blur of distance. Higher resolution images already exist, taken by the same telescope with longer exposures. The analysis will likely take a couple of years. The answer is coming. But while we wait, the alternative explanation for a genuine rotation deserves its own section, because it is far stranger than any optical illusion. If Betelgeuse really is rotating at 5 kilometers per second, if the measurement is genuine, then something extraordinary must have put that much angular momentum into a star this massive. The leading explanation has a name that does full justice to its nature: stellar cannibalism. When one star in a binary system grows large enough, its gravity begins pulling material away from its companion, layer by layer, stripping it down. That infalling gas carries the companion's angular momentum with it. The primary star grows not only in mass but in spin rate, accelerating far beyond what it could have achieved alone. In this scenario, Betelgeuse once had a companion. It ate it. The angular momentum it absorbed in the process is still written in its impossible spin. Mathematically plausible, observationally unverified, until 2023, when something new appeared in the brightness data. A new oscillation pattern, a pulsation cycle that matched none of Betelgeuse's known rhythms, began showing up with the regularity of something orbital, something with a fixed period around Betelgeuse. Something that was not Betelgeuse itself. What if Betelgeuse wasn't alone? What if a second star, a companion still alive, still orbiting, had been hidden inside the supergiant's glare for the entire history of human astronomy? The hypothetical companion was given a nickname, Beetlebuddy. Cute name. The implications were not cute. If it existed, it would explain the new oscillation. It would potentially explain the rotation anomaly. And it would fundamentally change every calculation about when and how Betelgeuse is going to die. For years, Beetlebuddy was just mathematics, a best guess assembled from decades of light-curve data. Nobody had ever seen it. The problem was geometry. Betelgeuse is so luminous that anything close to it vanishes into the glare. Imagine trying to spot a candle held next to a stadium floodlight from miles away. That was the contrast astronomers were fighting. In December of 2024, a team led by Steve Howell at NASA pointed an instrument called Allopeak at Betelgeuse. Allopeak sits on the 8-meter Gemini North Telescope in Hawaii. It is designed for exactly this kind of task, finding faint objects next to overwhelmingly bright ones. It takes thousands of ultra-fast snapshots, each lasting only 1/100th of a second, then stacks them in a way that mathematically erases atmospheric blur. The result lands at the absolute physical resolution limit of the telescope itself. The team chose their date carefully. If Beetlebuddy existed and followed the predicted orbital path, December 2024 was the moment it would be at maximum apparent separation from Betelgeuse, as far from the glare as it would ever get. The best observing window any astronomer was going to have. The same instrument had been pointed at Betelgeuse in 2020, during a phase when the companion, if real, should have been directly behind the supergiant from Earth's line of sight. The 2020 images showed nothing as expected. The 2024 images did not show nothing. There was a faint dot, slightly bluer than Betelgeuse, sitting at exactly the predicted angular separation and exactly the predicted position angle. After decades of theory, Beetlebuddy was real. Follow-up X-ray and ultraviolet observations released in 2025 sharpened the picture. The companion is a young star, approximately 1.5 times the mass of our Sun, almost certainly a pre-main sequence object, meaning it has not yet begun fusing hydrogen in its core. In stellar terms, it is a baby, still forming, still contracting, and that baby is orbiting so close to Betelgeuse that is embedded inside the supergiant's outer atmosphere, drifting through gas, 100 times thinner than the air in your living room, but still losing orbital energy with every pass. The companion is spiraling inward, slowly, measurably, inevitably inward. Within tens of thousands of years, Beetlebuddy will fall all the way in. It will be swallowed by the supergiant, likely feeding the very angular momentum that has had Betelgeuse spinning impossibly fast for so long. A young star, not yet fully born, being consumed by a dying one. The next observation window comes in November 2027, when the companion swings back out to maximum separation. By then, astronomers will have a far sharper picture of the orbit, the mass transfer rate, and exactly how much this hidden second star is shaping Betelgeuse's increasingly strange behavior. Betelgeuse is going to explode. That is not opinion. That is not speculation. It is an inevitability written into the physics of how massive stars end. Any star between roughly 10 and 20 times the mass of the Sun will eventually exhaust the fuel in its core, collapse under its own gravity, and detonate in a supernova. A blast so violent it can briefly outshine an entire galaxy. Betelgeuse is in that mass range. The fuel is almost gone, the clock is running, the hard part is the word almost. In stellar evolution, almost can cover a range from tomorrow to 100,000 years from now. Most estimates place Betelgeuse's remaining lifetime somewhere in that window, with some recent analyses, based on the strange behavior of the past 5 years, suggesting the window may be tighter. Tens of thousands of years rather than hundreds. A small number of astronomers have looked at the violence of the 2019 ejection, the new pulsation patterns, and the confirmed spiraling companion, and quietly raised the possibility that Betelgeuse may be in the final stages of core silicon burning. The very last stage, the one that ends in collapse within months. Almost certainly, this is not what is happening. The overwhelming probability is that Betelgeuse has thousands of years remaining, but almost certainly is doing a lot of work in that sentence, because nobody has ever watched a red supergiant in the final days before it detonated. We have no playbook. We do not know what the warning signs actually look like, because every supernova in human history was discovered after the fact. When Betelgeuse finally goes, here is what happens to anyone alive to see it. A point in the constellation Orion will brighten suddenly and overwhelmingly. Within hours, it will be visible in broad daylight. A hard white-blue spark where the warm red shoulder used to be. It will be brighter than the full moon. It will cast shadows at night. For roughly 3 months, it will be the second brightest object in the sky after the sun. Then it will fade. Over the course of a year, the brightness will drop and the color will shift. But the constellation Orion will be missing a shoulder, permanently. When the explosion subsides, the outer layers of Betelgeuse, hundreds of millions of miles of churning plasma, will be blasted outward in a shockwave moving at thousands of miles per second. What remains at the center will almost certainly be a neutron star, the collapsed core compressed beyond what atoms can withstand, where electrons are forced into protons and everything becomes a single ball of neutrons packed so tightly that a teaspoon of the material would weigh approximately 1 billion tons. In some scenarios, depending on the exact angular momentum of the collapsing core and the energy contributed by the infalling companion, the remnant may not be a neutron star at all. It may be a black hole. Betelgeuse may collapse entirely to a singularity, and we would watch it happen with no idea what the final state was until the light from it arrived. Will it be dangerous? Almost certainly not. At 640 light-years, Betelgeuse sits well outside the danger zone where a standard supernova can damage a planet. That zone extends only about 30 to 50 light-years. Betelgeuse is more than 10 times farther away. The one exception is a gamma-ray burst, produced when a collapsing star spins fast enough to focus lethal radiation into narrow beams. If one of those beams pointed at Earth, the consequences could be severe. But gamma-ray bursts require very specific stellar conditions, primarily Wolf-Rayet stars with extreme rotation, and the consensus is that Betelgeuse does not meet them. The Betelgeuse supernova will almost certainly be spectacular, unprecedented in human experience, and completely harmless. The neutrino pulse from the collapse will pass through the Earth and through every human body simultaneously. You will not feel a thing. What you will feel is something the physics cannot measure. Try to picture yourself on an ordinary Tuesday night, walking out to your driveway, looking up out of habit, and there in the sky, in the constellation you have known your whole life, is a light that should not be there. Brighter than the moon, casting hard shadows on the pavement. Your intellect will tell you that you are safe. Your body will not believe it now. The detail I promised at the start, the one nobody wants to say out loud. Betelgeuse is 640 light-years away. That number is not background information. It is the central fact of everything, and almost nobody fully sits with what it means. Light from Betelgeuse takes 640 years to reach Earth. When you look at Betelgeuse tonight, you are not looking at Betelgeuse. You are looking at a 640-year-old recording of Betelgeuse. The light hitting your eyes left that star around the year 1386. Geoffrey Chaucer was writing the Canterbury Tales. Europe was still recovering from the Black Death. The 100 Years' War had 67 more years to run. The great dimming we watched with such intense attention in 2019, that actually happened around the year 1379. The rebrightening that followed, 1380. The strange new pulsations we have spent years debating, the 1380s. We have been watching the medieval life of a star and calling it current events. Whatever Betelgeuse is doing tonight, in the actual present, in the year 2026, we will not find out about it until the year 2666. And that means nobody alive can tell you the true current state of Betelgeuse. Not NASA, not ESA, not any telescope ever built or planned. The version we observe is a recording, very detailed, very beautiful, but a recording, which means Betelgeuse may have already exploded. Not theoretically, literally. The light from its death could be right now somewhere in the dark between us and it, falling toward Earth at the speed of light, 100 years away, perhaps 1,000, perhaps less. Perhaps it will arrive in 2100, perhaps 2500, perhaps sometime next week. We have no way to know, because we do not have access to the star. We have access only to the light it sent us, and that light is centuries old by the time it arrives. That is the part I keep coming back to, not the rotation, not the companion, not the supernova itself. The patience of the light. The fact that whatever Betelgeuse is going to do, it has already done it. The event has happened or it has not. The star exists in its current form or it does not. And we are simply waiting, without knowing we are waiting, for the message to arrive. You started this video thinking Betelgeuse was a bright red star in a familiar constellation. Now you know what it actually is. Let every thread close. Betelgeuse is a red supergiant so enormous that placed where our sun is, it would swallow every planet out to Jupiter, a star in its death throes, pulsing and heaving and shedding material in ways no standard model fully predicted. It is rotating impossibly fast, approximately 5 kilometers per second, confirmed by Doppler shift measurements from the ALMA array, far beyond what conservation of angular momentum allows for a star this massive. That rotation may be an optical illusion. Betelgeuse's violent surface turbulence would be misread as fast rotation approximately 90% of the time by current instruments, meaning the rotation problem may not exist at all, or the rotation may be real, the product of stellar cannibalism, a companion star consumed long ago whose angular momentum was absorbed and never dissipated. The Great Dimming of 2019 was not a supernova precursor. It was a massive plasma ejection that cooled into dust, combined with a cold surface patch, viewed from the worst possible angle, but the underlying cause of that ejection remains unexplained by standard models. Betelgeuse is real, a young pre-main sequence star of approximately 1.5 solar masses, confirmed in December 2024 by the Alapeak instrument on Gemini North, currently orbiting inside Betelgeuse's own atmosphere and slowly spiraling inward toward inevitable consumption. Betelgeuse will explode as a Type II supernova, visible in daylight, brighter than the full moon, casting shadows at night, permanently removing the shoulder from Orion, with a timeline somewhere between tomorrow and 100,000 years from now. With no reliable method to narrow that range, the explosion is almost certainly safe. At 640 light-years, the lethal effects fall short of Earth by a factor of 10, and Betelgeuse does not meet the conditions for a gamma-ray burst. And the deepest truth, the light you see tonight left Betelgeuse in 1386. Betelgeuse may have already exploded. The light from its death may be en route right now. We cannot know. We are watching a very old message and waiting, without knowing we are waiting, for the next one. Somewhere out there, 640 light-years away, the real Betelgeuse exists in a state we cannot access. It is either still alive, still churning, still boiling, still carrying its impossible rotation and its embedded companion spiraling inward toward catastrophe, or it is already gone. And one night, on some perfectly ordinary evening, someone will walk outside, look up, and see something in the sky where a familiar red star used to glow, brighter than the moon, casting shadows on the pavement. They will feel, in their body, like they are witnessing something happening. They will not be. They will be receiving a letter. A letter written 640 years ago by a dying star, sealed in light, mailed across the dark at the fastest speed the universe allows, that simply, finally, after all that distance, after all that silence, found us. Whatever Betelgeuse is going to do, it has already done it. We just haven't heard yet. Thanks for watching. See you in the next one.